If you've watched my other videos on the microbiome, then you already know how important it is for good health. So, how do we keep our microbiome healthy? One of the most important things we can do is to keep it acidic. Healthy stool should have a pH of 6.2 or less. This is due to the formation of short-chain fatty acids, yet most of us have a stool pH of 7.0 or higher. Once stool pH goes over 6.6, we see the growth of toxic bacteria, fungi, and parasites. We can get the formation of putrefying amines like cadaverine and putrescine, and the formation of toxic gases like methane, hydrogen sulfide, and ammonia. If you've ever canned food, you know that you can only can acidic food. If food isn't acidic enough, it can create botulism and get people sick who eat it. It is the same for our microbiome. A neutral or alkaline microbiome is like a bad canning operation. It's toxic. All of the toxins from a neutral or alkaline microbiome will get into our bloodstream and our internal organs and our brain and decrease our vitality. Before antibiotics, the stool pH of breastfed infants was below 5.0. Even now in rural parts of Africa it is 5.7, but here in the United States it averages above 7.0. So, let's talk about what makes stool go alkaline and how to get our microbiome back to a healthy acidic state. There are two ways that stool goes alkaline. The first is that the microbiome simply doesn't make enough short-chain fatty acids to acidify the stool in the first place. The second is the formation of ammonia in the large intestine. Ammonia is very alkaline, and we don't want our body to be making it in the large intestine. In terms of not making enough short-chain fatty acids, this is mostly due to diet. Our Stone Age ancestors ate much more fiber than we did, and all that fiber, what we would call prebiotics today, fed the bifidus and lactic acid producing bacteria in the ascending colon and made plenty of short-chain fatty acids to keep the microbiome at a healthy acidic level. So the first thing we want to do is give enough prebiotics, specifically the ones for bifidus and lactic acid bacteria, to generate enough short-chain fatty acids in the first place. The second issue is ammonia formation. The body is always making ammonia. Our digestive process makes it when it breaks down proteins. Our cells make it when they recycle protein. Normally, this isn't a problem. Ammonia goes to the liver, which combines it with bicarbonate to form urea, 75% of which is then excreted by the kidneys, and the remaining 25% is excreted by the large intestine. However, this process requires that we have enough bicarbonate in our bloodstream to turn the ammonia into urea, and most of us are bicarbonate deficient. For more information on bicarbonates, you may want to watch our bicarbonate video that explains this in more detail. There is, however, another way our ammonia system derails, and that is with a bad microbiome. Certain bacteria, fungi, and parasites have a special enzyme called Urias. It allows them to take the 25% of the body's urea that goes into the large intestine and turn it back into ammonia and bicarbonate, both of which are highly alkaline. Bacteria like Staphylococcus, Klebsiella, Proteus, H. pylori, Nocardia, and Pseudomonas can do this, as well as fungi like Candida and Cryptococcus neoformans. These urease-expressing infections are at the crossroads of our health. There are many more bad bacteria that can thrive in an alkaline or even neutral pH large intestine, but that do not themselves make urease. They rely on these urease-expressing infections to alkalinize or bring to neutral the pH of the large intestine so that they can then grow. These urease-expressing infections are the linchpin. If they are present, they make the ammonia that enables other bad bacteria, fungi, and parasites to thrive. The ammonia they make is then sent back to the liver, where we must expend additional energy to turn it back into urea, only for that urea to get back into the large intestine and feed these infections and make more ammonia again in a vicious cycle. Our liver ends up providing the metabolic energy for these bad bugs, and we lose energy and get toxins in return, including ammonia, which causes brain fog and other issues. These bugs end up getting a free lunch. Ammonia causes all the membranes of the body to leak. Ammonia also causes calcium to precipitate in the tissue. It's been said we turn to stone as we age. Part of this process is caused by ammonia. If you get some 0 to 100 parts per million ammonia test strips, you can see how much ammonia is coming out of your urine, and this is an inexpensive way to test your ammonia and therefore your urease infection levels. Optimally, your ammonia levels would be under 100. The lower, the better. Any ammonia coming out of your urine is ammonia that was above and beyond your body's ability to turn it into urea. If your urine hits 100 on the test strip, keep diluting your urine until you get a reading between 0 and 100, and then do the calculation. It's not unusual to have ammonia levels over 500 for some people. So, we need to knock out these urease-expressing infections, but how? It turns out that there are a number of plant extracts we can use, including spearmint, hibiscus, pomegranate rind, and geranium flower. To this end, I've created Pokegeshi powder. It contains the prebiotics needed to support the acidifying bifidus and lactic acid bacteria of the ascending colon, as well as 5 different plant extracts to support the body in dealing with urease-expressing infections. You can mix it in water and juice. Personally, I like to mix it with hot water and drink it as a tea. If you have any questions about how to use Pokegeshi powder, feel free to contact us. Take care.